Understand, can you move a bit slowly?
Yes, sir. We are not. We are not.
Yes, sir.
Slowly, sir.
We can able to understand, sir.
Yes, sir.
Sir, we can understand, sir.
No, sir.
No problem.
Can't understand, sir.
Sir, can you please mute? Sir, can you please mute us?
Sir, could you please mute everyone? We are unable to understand the class.
Yes, sir. We can't understand, sir. Can you tell it?
Sir, when was the permutations and combinations?
Sir, Sridhar sir to repeat once more, sir.
Sir, can you explain the homework?
Sir.
Unmute everyone. Mute everyone.
Mute everyone.
Okay, sir.
Sir, please mute everyone.
Okay. Sir.
Teacher, last time what you discussed in the history class? Sir, can you explain a bit slowly?
Yeah.
Thank you, understand. Gas.
Good evening, sir.
Sir, can you explain the homework sums?
Sir, can you explain the homework sum, sir?
Yes, sir. Can you explain?
Sir, please explain the homework sum.
We are getting some doubts, sir.
Sir, could you please give us time to take a screenshot?
Sir, give time to take
Sir, give time to
When is doubt session, sir? Sir, when is doubt session?
Sir, could you please allow us to take time to take a screenshot, sir?
Yes, sir.
Yes, sir.
Hi, sir.
Sir, can we know when is doubt session, sir?
Yes, sir.
Sir,
Yes, sir.
sir, we need a session to get all our problems.
Sir, explain the homework.
Sir, can
explain slowly, sir. We are not
Sir,
able to
please mute yourself.
Sir, can you explain slowly, sir?
Yes, sir. So slowly.
Sir, we receive homework problems.
Stop it. Don't explain so
Can
fast.
please continue?
So someone is screen sharing.
Sir, you better mute everyone.
Sir, motherfucker.
Hello.
Sir,
Sir, can you explain slowly, sir?
Sir, please explain slowly.
Good evening, sir.
Could you please let us to take a
Please explain slowly, sir.
Sir, start online classes.
Sir,
Please
Sir, after explaining the question, give
Sir, who is that?
screenshot and copy.
Sir, mute.
good evening,
Don't
sir.
wait, sir. Good evening, sir. Good evening, sir.
Good evening, sir.
Good evening, sir.
Good evening, sir.
good morning, sir.
You teach bit slow, sir. We are not able to understand, sir.
Denike.
Hello. Hello.
Sir, mute everyone.
Lakshmikant sir, please turn on your video and please raise your hands.
Yeah, I turned on video only, sir.
Just a minute. Yeah, already you have the co-host, no sir?
Yes, sir. Yes, sir. I have, sir.
Okay. Dear students, here tomorrow also we are conducting the classes. The first point, everyone please note down. And another point is, if you are all talking at a time, we are unable to continue the class. So if you are because of you are all speaking at a time, we are muting all. So if you are all keep quiet and one by one, if you have any doubts, it is possible. See, within just 2-3 minutes, how the class seems to be disturbed. So that is the reason in online classes, it is highly difficult to clarify the doubts, because if we are clarifying the one student doubt, other student is unmuting themselves and they are speaking. Which creates disturbance to others. So Lakshmikant sir, a small request.
Yes, sir.
Once you are moving the page upside, give 1 minute,
sir.
1 minute or 2 minutes time for the students to take the screenshot. So majority of the
Okay, sir.
students, they are expecting a small time to take the screenshot. Once you are
Yeah,
moving
I'll
the screen,
go through once. If you want now also, you can take screenshot.
yeah.
All the notes available. If you want,
And,
I'll send PDF also. if
Yes, that's
needed.
what I want to request you, sir. If possible, please send the PDF copy to us so that we will
Okay, sir.
forward this PDF copies to the students so that they will refer at homes. Please
Yes,
continue the
sir.
class, sir. Thank you so much. Tomorrow class as
Okay,
usual
sir.
timings, my dear students, 8 to 9. Sir will take the class tomorrow also, even it is Sunday, because we have a very less time in our hand. So tomorrow also we are planning to conduct the classes. So you can arrange your timings, adjust your timings and attend the class at 8 o'clock. Lakshmikant sir, thank you so much. Please continue the class.
Okay, sir. Thank you, sir. Thank you, sir. Okay, ma, we will share the notes also. No need to worry. In PDF format, I am going to share the notes. Okay. Okay, ma. See, a very good evening to all and welcome to all of you to the math session. See, in this session, we are going to learn about base system. A few more problems we are going to solve now. See, yesterday we have learned introduction about the base system and a few Ioqm problems. Now, in this session, we will cover few more problems. See, before we step on to the solving few problems, let me revise once again about the base system. Just a brief introduction I'm going to give. See, base system is nothing but we already know decimal system. See, decimal system is nothing but the number system which we are going to use. That system we call it as a decimal number system. Okay. See, for example, you are taking 543. Let us example. So base 10. So here we need to look at the place values. Everyone knows, right? 543 is nothing but what? Units place is 3, 10 power 0. So 4 is nothing but what? 10 power 1. So this is 10's place. 10 square. 5 is nothing but 10 square. So how do we write this? This one we are going to write 5 into 10 square plus 4 into 10 power 1 plus 3 into 10 power 0. Like this we are going to write. Now similarly, when you take any number, let us say some number A, B, C, D. Okay. Let us consider base x. See, this is the number in base x system. This is the number in base x system. This is the number in base x system. So how do we convert into decimal number system? See, what are the place values? See how we follow in the decimal number system, same way here also. So this is place value is x to the power 0. What are the place value of this x to the power 1? This is x square. This is x power 3. So which can be written as a times x power 3 plus b times x square plus c times x plus d we are going to write. Okay. Similarly, we are going to write like this. So yesterday we have converted from decimal to binary, binary to decimal, and any base to any other base. I'll give one small example again to revise. See, you take any number, let us say 25. So convert to 25 into base 3 system. Let us say, for example, if they give like this question, convert 25 base 10 to base 3 system. Base 3 system. So how to convert? We have to divide this 25 by 3. So how many times it goes? 3 times 24. Remainder is 1. Now 3 times 2. What is this remainder? 6. So remainder will be 2. So what you can write? This one you can write as 221 base 3. So the decimal number 25 in base 10 system, which can be written as in base 3, 221 base 3. So how to verify whether our answer is correct or not? Now convert this base to decimal number system. So how can we convert 2 to 1, right? Base 3. Base 3 is nothing but how to write 3 power 0, 3 power 1, 3 square. Now you can convert, right? 3 square into 2, 3 square into 2 plus 3 into 2 plus 3 power 0, 1 into 1. So what is this? 9 into 2, 18 plus 6 plus 1. So is it 25? So this is how we converted. Now in this session, see, we are going to solve a few more problems here. See, let us take one example here. Okay. See, look at this is the question. ABC base 7. See, a 3-digit number is given. A 3-digit number in base 3. A 3-digit number in base 7 is given. See, now a 3-digit number is given. So a 3-digit number ABC in base 7. See here a 3-digit number. ABC is a 3-digit number. This number is in base 7. Now CBA is a 3-digit number. This number is in base 9. How many such numbers are possible? This is the question. And we have already learned in the previous class. See, if the base is 10, if the base is 10, what are the digits we are going to get in the decimal number system? We are going to use the digits from 0, 1, 2, 3, and so on up to 9. See, if the base is 2, what are the digits we get? 0 and 1. If the base is 3, what are the digits we get? 0, 1, 2. If the base is 4, what are the digits we are going to get? 0, 1, 2, 3. Similarly, look at here base 7 is given, base 9 is given. Base 7 means what are ABC? So ABC should lie from where? 0 to 6. Now from this condition, what you can say here, B base is 9. So CBA should vary from 0 to 8. Okay. Now what are the common values? Look at here. ABC here 0 to 8, ABC 0 to 9. What do you understand this? Now ABC can vary from 0 to 8. And look at here, this is the 3-digit number. Because ABC is a 3-digit number, CBA is a 3-digit number. So now A cannot be 0. A cannot be 0. And C also cannot be 0. Why? Because the first digit can't be 0. So A you cannot take 0 and C you cannot take 0. And we can't take C cannot be 0. C cannot be 0. Now first, now we know the place values, right? So how to write here? Now we can write here ABC base 7 is equal to CBA base 9. Now how can we write? We know the place values, right? What is the place value of C? 1. 7 power 0 is nothing but 1. So B means 7. So A means 7 square. This is 9. 9 power 0, 1, 9. So this is 9 square. Now multiply and add. So 7 square into 9. Is it 49A? Plus 7 into B, is it 7B plus C is equal to what is this? 81 into C, 81C plus 9 into B, 9B plus C. We can simplify like this. Now let us simplify this. So how can we simplify? So let us bring B to one side and A to another side. Will simplify. See, let us write. See, 49A minus A. Now remaining terms you send this side. So 9B minus 7, 9B minus 7B plus. So you can write this one as 81. So this is 81. So now how can we simplify this? See, 49 minus A, what? Is it 48A? Is equal to what is 9B minus B? Is it 2B? Plus this is what 81 you will get. Okay, so now this is how we will simplify here. Now see, now this equation we have to simplify. So ABC base 7, so CBA base 9, so 81A, sorry, so 81C, 81C, okay, 81C plus 9B plus C, right? So now let us simplify this. A we are sending that side. So 81C minus C plus 9B minus 7B. So how can we write this one? This is 80C plus 2B. Now let us divide this equation by 2. See, here we have 80C. Now you divide this equation by 2. What we are going to get? 24A is equal to 40C plus B. This is the what we earn. Now we already know that here ABC ranges from where? ABC vary from 0 to 6. ABC vary from 0 to 6. We can clearly look at here, ABC can vary from 0 to 6. So now 24A is there. Here, look at here, 24A is there. See, what is the maximum possible value of 24A? 24A maximum value. What is the maximum value 24A can get? Because A maximum value we can take 6 only, right? So we can write 24 times 6. So 144 is the maximum value. Now we are going to check one by one. So ABC should range from where to where? ABC value can vary from 0 to 6. Okay. Now initially you take here B0. See, if we take B0, what do you get here? 24A is equal to 40C, right? So this is A by C. So now what are the values we will get here? Now C, AB should be, so 24A is equal to 40C. Now A value we should get integers from 0 to 6. So now is there any possibility? 24, so you can cancel 6. This is 10. So what do you get here? A is equal to 2 times 3, 2 times 5. So 5C3 by. So this is not possible. Or so better we can take C value. We can easily get also. So or we can take C value. So we'll get easily. So now you can take here, we have to check values like this. See, ABC values we already there, right? 0 less than or equal to, ABC less than or equal to 6. See, one by one we should check values, so that we should find out B and C values. So from this, how many such values are possible? So those values we have to check here. Okay. So like that, one by one you take screenshot. I will write in the next page. Okay, so I'll tell you. Now here we can take 24 is equal to 40C, B plus 40C. So C values we can take, because C values if you take, B ranges we easily get. Now look at here, C cannot be 0. We can clearly see here C cannot be 0. Now put C is equal to 1. See, when you put C is equal to 1, so what values you will get here? C is equal to 1. So 24A is equal to 40 plus B. 40 plus B. We already know that A, B, C are digits, right? See, 24A is equal to 40 plus B. A, B, C are digits. We already know that A, B, C are digits. See, B can vary from where to where? B can vary from 0, 1, 2, 3 and so on 6. So if I take B is equal to 0, 1, 2, 3 and so on up to 6. What is 24A value? 24 value will get 40, 41, 42 and so on up to 46 you will get. Okay. So is there any multiple of 24A? Because A value we should get integer. A value we should get integer. We don't get any integer here, right? 24A is equal to 40. We don't get A integer. So this is not possible. No value of A we will get from this case. Hope it is clear. See, we have written one equation, that is 24A is equal to 40C plus B. So here we already know that the range of digits ABC from 0 to 6. First we are checking with C. C is equal to 1. Now C is equal to 1 and we already know that ABC varies from 0 to 6. So here 24A is equal to 40 plus B. Now check for B values 0, 1, 2, 3 and so on 6. So nowhere we will get 24A multiples. So definitely A integer not possible in this case. So A is not possible here, because ABC should vary from 0 to 6. See, 24 into 1 what? 24. 24 into 2, 48 will come. So 48 not there right here. So definitely A is not possible. Okay. So hope it is clear. So next we'll check for B value 2. So what you can write here? 24A is equal to 40C plus B. 40C plus B. Now C value you can take 2. If you take 2, what will happen? 24A is equal to 40 into 2, 80 plus B, 80 plus B. So now B varies from where? B can be 0, 1, 2, 3, and so on up to 6. So is there any value possible here? See, 24A is equal to B0 means 80 will come. B1 means 81 will come. B2 means 82 will come, and so on up to 86. Okay. So see, is there any multiple of 24 here? 24, 48, right? So next 72, then 96. So here also we don't get any multiple. So this is also not possible. See, next you take the case C is equal to 3. C is equal to okay. See, look at here now here. See, see now here C is equal to 23. See now 24A varies from where to where? See 24A varies from now C is equal to 23. So now here you can write this one 40C. 40C means what? You can write 120 plus B, right? So you can write 120 plus B. Now B is equal to 0. See, B varies from where? B is equal to 0, 1, 2, 3, and so on up to 6 it will vary. See now 24A if you keep. So 120 plus 0, 120 will get 121 and so on 126 you will get. Now look at here 24A into 24A is equal to 120, right? What is the value of A you will get? See, A is equal to 5 is possible, right? So 20 into 500, so 120 will get. A5 is possible, and for what value of B we are getting? B is equal to 0 and C is equal to 3. So hope it is clear. Now A5, B0, C3 will get. See now next case is not possible. See now take screenshot here. See the next case is not possible. Why? Because when you take C is equal to 4. So when you take C is equal to 4, what you are getting here? 24A is equal to 40C plus B, right? C4 means what will happen? It will exceed 144. See, 24A is equal to 40 into 4 plus B. So what is this value? 160 plus B. 160 plus B. So 24 maximum value how much? See, we have already learned maximum value. Maximum value of 24A is how much? 144 only will get. So there is only one case possible. What is that? A5, B0, C3. So hope it is clear. A5, B0, C3 only possible. Okay, so now we got the values. So what are the values we got? A5, B0, C3 are possible, right? Now what is this? ABC base 7 is equal to CBA base 9. See, we can verify our answer correct or not. ABC is what? 503 base 7 is equal to CBA. So 305 base 9. See, we can verify this. So how to verify? We already know the place values. This is 1, 7 and 49. So 49 into 5 plus 3 you will get. So 5 9 is 45. 45, 22, 45 plus 3. So what you will get? 248 you will get. Similarly, here also we can simplify. So this is 81 into 3 plus 5. So 243 plus 5. So you will get 248. So how many such numbers are possible? Only one number is possible. Only one number is possible. So what is that number? Is nothing but, so you can take 503 in base 7 is equal to 305 in base 7. The digits are reversed. Okay, hope it is clear. And now the very important points we need to know in this base system. So what are the minimum values? What are the maximum values also we should learn. See, for example, you take decimal number system. Decimal number system. We already know what is minimum number, maximum number. See, decimal number system, what is the minimum 2-digit number? For example, what is minimum 2-digit number? Everyone knows minimum 2-digit number is what? 10. Minimum 2-digit number is 10 in base 10 system. So what is maximum 2-digit number? See, maximum 2-digit number is what? 99 base 10. Why? Because here in the base 10 system, because in the base 10 system, digits from where to where? 0, 1, 2, 3, 4 and so on up to 9. So minimum number means what? First digit cannot be 0. First digit cannot be 0. We are putting 1, right? Now maximum means what? What are the maximum possible digit? 9. For example, minimum 3-digit number in base 10 system. How do we write? 100, because first digit cannot be 0. 100 in base 10. What is maximum 3-digit number? So what is maximum 3-digit number in a base 10 system? So you can write 999 base 10. So you can write like this. So now similarly, when you come to base 3 system, base 5 system or anything, how to write? See, let us take for example base 5 system. Base 5 system. What is the minimum number? So minimum 3-digit number. Let us say for example minimum 3-digit number. See, minimum 3-digit number, how to find out? See, in base 5 system means what are the digits? In base 5 system, the digits from where to where? 0, 1, 2, 3, 4. Digits from 1, 2, 3, 4. First digit cannot be 0, right? We'll put 1. 3-digit, right? So 100 in base 5 system. This is the minimum 3-digit number. What is the maximum 3-digit number? See, what is the maximum possibility for 3-digit number? Maximum possibility 4, right? 4444 base 5, because 5 is not possible. 5 if you write like this 5, this is invalid. This is invalid because the base is 5. So you cannot take digits here 5. The digits from 0 to 4 only. 0, 1, 2, 3, 4 only. So this is the maximum 3-digit number in a base 5. Now see, while converting, we have to learn one logic. See, for example, you are writing maximum. See, 9 I am taking. Maximum 1-digit number. How can I write? Can I write 10 power 1 minus 1? See, maximum 2-digit number. 99, right? We can write this one as 10 square minus 1. Maximum 3-digit number. 999. We can write it as 10 power 3 minus 1. We can write like this. See, for example, similarly, you take this number. So what is this number? 444 base 5. See, it is a 3-digit number. When you convert into decimal number, see, look at here 99. Since it is base 10 system, 10 square minus 1. So now look at here, what is this one? This is base 5 system. What will be the next one? So next one you will get 3-digit number, right? So it will be 5 cube minus 1. See, even if we simplify also we'll get, look at here, this is 5 power 0, right? What is the place value of this? This is 5. What is the place value of this? 5 square. Now simplify this. 4 into 5 square plus 4 into 5 plus 4 into 1. Now 4 into 25, 100 plus 20 plus 4. So is it 124? Now 5 cube minus 1 is also what? 124. So if you know this, we can save a lot of time here. See, whenever you come across maximum digit number, so you can upgrade to next number. See, for example, 666, like base 7 is given. See, is it a maximum number in base 7 system? Maximum 3-digit number in base 7 system? So what is this value? What is this value in decimal number? Is 7 power 3 minus 1. Hope it is clear. See, let us say, for example, 888 base 9 system. So this is the maximum 3-digit number, right? Maximum 3-digit number. Maximum 3-digit number in a base 9 system. Base 9 system. How can we write this one? This one we can write it as 9 power 3 minus 1. So this is how we can easily write. We can also simplify like this. So this is 9 power 0, 1. So 9 power 1, 9. So 9 square. Even if you multiply and add, we will get the same answer. So 9 power 3 minus 1. So based on this, we will solve one problem. So note down these points. Okay, see, I'm going to paste the question here. Yeah, and look at here. See how many 3-digit numbers in decimal system or 3-digit numbers in base 9 and base 11 system. See, this is the question. Okay, so first, whatever the numbers are there, we have to convert into decimal number system. See, now we received here. So how many 3-digit numbers are in base decimal system or 3-digit numbers in a base 9 system and base 11 system? See, what you need to do here is first write 3-digit numbers range in a base 9 system. See, 3-digit numbers in base 9 system I will write. Base 9. See, what is minimum 3-digit number? Minimum 3-digit number. Minimum 3-digit number. See, in base 9 system, what are the digits vary from 0, 1, 2, 3 up to 8, right? So minimum 3-digit number in any base, minimum 3-digit number will be 100 only. 100 base 9, right? This point you need to know. Now, what is the maximum digit number? So maximum 3-digit number in base 9. See, just now we have learned how to write maximum 3-digit number in base 9. What? Base 9 is base 9. What are the digits? Digits from 0, 1 to 8, right? 0, 1, 2, 3 and so on up to 8. Now, what is the maximum 3-digit number? Maximum 3-digit number is nothing but this is 8, 8, 8. This is the maximum 3. See, in base 9, maximum possible digit is 8. So 8, 8, 8, base 9. See, we know how to write this, right? So what are the place values? You can take 1, 9, 9 square. Or just now we have learnt maximum 3-digit number means how to convert into decimal number. Decimal number is what? This is 9 power 3 minus 1. Now how to convert this one? These are the place values, right? 1, 9 and 9 square, right? These are the place values. We can easily write. So now you can write the place values. This is 1, 9 and 9 square. So is it 81? This is 81, right? 81 base 10 to now 9 cube minus 1. 9 cube minus 1 means what? 729 minus 1, right? 728 base 10. So in decimal system, the number 81 to 728. All these numbers are 3-digit numbers in base 9. See, 81 is a 2-digit number. 2-digit number in 81 is a 2-digit number. 2-digit number in base 10 system. But whereas in the base 9 system is it is a 3 digit number. Okay, so what we do here is we are going to write the range of base 11 3-digit numbers, and we are going to find out common numbers, common numbers. So what you will write here now? So now let us write. Now base 9 is completed, right? Now this range you take. So 81 base 10 to 81 to 728 base 10. So let us say this is equation number 1. Now we have to find out base 11, right? So we have to find out base 11. So what are the base 11? Now write here base 11 number. So what is the minimum 3-digit number in base 11 system? So minimum 3-digit number, in base 11. See, in any base, minimum 3-digit number, first digit cannot be 0, 1, and remaining 2 digits are 0. So 100. Now here the base is 11. Now what is now this one you convert into decimal number. So how can we convert decimal? So place values 11, 11 power 0, 11 and 11 square. So you can write this one as 1 and this as 11 and this as 11 square. So what is this value? 11 square. So 121 in base 10. Right. Now find the maximum digit number. So what is your maximum 3-digit number? Maximum 3-digit number in base 11. See, in base 11, what are the digits? Digits vary from 0, 1, 2, 3, right? 0, 1, 2, 3, and so on up to when? Up to we'll get 10. 10 is nothing but A, right? So 10. This 10 is nothing but A. Okay. So we can write this one as A, base 11. Okay. How to convert into decimal form? Is it 11 power 3 minus 1? So 11 power 3 minus 1. So now definitely this is greater than 720, right? 11 cube is I think 1331. So 1331 minus 1. So 1330. So it is anyway greater than 728. So 1330. See, now look at here. Here the number varies from where to where? 121 to 1330 base 10 system. Now let us say this is the equation number 2. See, a number should be 3-digit number in base 9 as well as 3-digit number in base 11 also. Base 9. Look at here base 9 up to 728 only. Up to 728 only you will get a 3-digit number. So when you take 729 is a 4-digit number in base 9. 729 is a 4-digit number in base 9. So now we cannot take. So what is 729 here? 1300 base 9 is nothing but 729, right? But here a number should be 3-digit number in base 9 and base 11. So what we have done is we have written a minimum 3-digit number in base 9. We have written maximum 3-digit number in base 9. We have converted into decimal number. Now similarly, next one here, base 11 we have taken. Minimum 3-digit number we have written in base 11 system, and maximum 3-digit number we have written in base 11 system. Now both, right? Both the cases we should consider. So what are the common values? Common values from where to where? So is it from 121 to 728? So to understand, just to take one line. So let us take one line like this. Now here the numbers from 81 to 728. Let us say this is 81 to 728. Okay, so you can take like this, 81 to 728. So you take here, this is 81 to 728. So this is first one. Now look at here, the numbers varies from where to where? 121, somewhere between here, 121 to 1330. So this is 1330. So it is anyway greater than 720. No problem. 120. Now what are the common values? Can we clearly see here? These are the common values. Now 121 to 708. So numbers from, so numbers from 121 to 121 to are there. So look at here. So we can do this one 121 to 728. So now you can find out numbers are total numbers. Numbers are 728 minus 121. So because 121 and 728 both are included, right? So we have to add one. Otherwise, you do one thing. So 1 to 121, now 1 to 728 will add, right? See now total 728 numbers, we should subtract 121. Okay, so 120 we should subtract. See, like that also we can do, right? See why we are adding one, you may get doubt. So here 121 is included and 728 is also included. So you can take like this also, you can understand 1, 2, 3, 120 you take. Now 121 and so on 720. See total 728 numbers are there, right? Among this you should subtract till 120. So when you subtract 120, how many digits you will get? So 608 numbers will get. So 608 numbers are 3-digit numbers in base 9 as well as in base 11. So in both the systems, it will be 3-digit number only. Okay. Okay, so hope it is clear. So similarly, I'll give one homework question from this model. So this one you do as a homework. So how many 3-digit numbers in base 10 are there? Which are 3-digit numbers in base 9, 3-digit numbers in base 6, and 3-digit numbers in base 5. See, very simple. Convert it into decimal number and find the common values in all the 3 cases. Okay. So now next, see now this is how next we are going to learn about related to congruency model problems. So these are the very important problems, congruency models. So congruence model problems. See what is mean by congruence here. See the congruence means you take 2 numbers. Let us say A and B. Let us say A and B. So A is congruent to B mod M. So what is the meaning of this? So I'm going to explain what is the meaning of this. This meaning is A and B are having same reminders, when we divided by M. So A and B are having same reminders. See, let us take for example any number. Let us take you take 17. 17 you divide by any number. Let us say some mod 5. Okay. So when you divide 17 by 5, what is the remainder? So we'll get 2. So 17 is congruent to 2. So not only 2. See, you can add 5. For example, 17 is congruent to 7 mod 5 also we can write. So how means? Because now divide 17 by 5. What is the remainder? 2, right? Divide 17 by 5, remainder 2. Divide 7 by 5. What is remainder? 2 you will get that. So what can we say from this? A and B, the numbers A and B are having same reminders when we divide by this divisor M. Okay, this is the meaning. So which can be written as A is congruent to, which can be read as A is congruent to B modulo M. A is congruent to B modulo M. So this is how you can read. So hope you understood. So here meaning they are having same reminders. So A and B are having same reminders. See, let us take for example 35. So 35 is congruent to, let us say, mod some 8. So 8 4 how much? 32, right? Remainder is 3. So now 35 and 3 are having same reminders or not when we divide by 8? 35 by 8. 8 4 32. Remainder is 3. Now here 3. So 3 is nothing but what? Here also remainder 3. Not only these 2 numbers. See, you can add 8 to this. 35 is congruent to 11 mod 8. You can also take like this. See, what is here 35 means what is the remainder here when you divide by 8? Remainder is 3. Now, what is here when you divide 11 by 8? Remainder 3. So, A and B leaves the same remainders when we divided by mod n. So, hope it is clear. Or you can also, let us take one more example. Let us say 54. 54 is congruent to dash mod 11. Okay. See, 11 4 is how much? 44, right? So what is the remainder here? 10. See, when you divide 54 by 11, remainder is 10. Remainder is 10 because 11 4 is 44, 10. Now when you divide 10 by 11, so here also remainder 10. So when we divide 54 and 10 by 11, so they are leaving the same remainder. So you can write like this. Okay. So see, you can also take, for example, 54 you take. So add 11 to this, 21. 21, right? This is mod 11. This is also correct. This is also correct. Why? Because 54 is what? When you divide 11 by 54, here the remainder is 10. Here also remainder is 10. So you can write like this. Okay. So we can write like this. Now here you need to understand this thing. Now let us take, for example, A is congruent to B mod m. B mod m. So now just now we have taken example. Now 17 is congruent to dash mod 5 is given, for example. See, now what is the remainder when we divide 17 by 5? 2. Can we write like this? Now we can subtract here 2 on both sides. So 17, when you divide 17 by 5, remainder is 2. So now can I subtract here 17 minus 2 congruent to 2 minus 2 mod 5? Now what will happen? 17 minus 2 is nothing but 15. 15 is congruent to 0 mod 5. What is the meaning of this? When you divide 15 by 5, it is leaving the remainder 0, right? So now which can be written as? Now we can subtract here, right? Now A is congruent to B mod m can also be written as A minus B. We are subtracting B on both sides. A minus B is congruent to 0 mod m. So A minus B is congruent to 0 mod m. We can also write like this. And another way, look at here. When you divide this 15 by 5, it is leaving the remainder. So can we say now 5 is a factor of 15? We can say, right? Because 5 exactly divides 15. 5 divides 15 exactly. So now 5 is a factor of 15. Now similarly here you can write A minus B. So what you can write here, we write now 15 is equal to 5 into 3. So here also you can write A minus B is equal to m into some constant k. You can write m into some constant k. And you can write here m divides A minus B. We can write like this. See, from all these points you should understand. So what are the points you can write? See, A is congruent to B mod m. Okay, which can also be written as A minus B is congruent to 0 mod m. And what is another point you can write? A minus B is equal to m into some constant k. And we can also write m divides A minus B. See, all these four are same, which gives the same meaning. Okay, while solving problems, we need to find the differences from this. Now, so from this, we are going to see the few properties. See, for example, if you get like this, if A is congruent to B mod m, okay, and B is congruent to C mod m, okay, then A is congruent to C mod m, then A is congruent to C mod m. So how to prove this? First two cases, see, A minus B is congruent to mod m, right? So we can prove this. How can we prove? A is congruent to B mod m. A is congruent to B mod m means what? A and B are having same remainders when we divide by m. So can we write A minus B is equal to m into some constant k or anything, m into some constant k1, right? Next one, what we have, another point we have, B is congruent to C mod m. So how can we write now? B minus C is congruent to 0 mod m, right? 0 mod m. So I can write direct step also. So hope it is clear. B minus C is congruent to 0 module. So how can we write now BC, B minus C? B minus C is nothing but B minus C is nothing but M into some constant K1. So you can write here B minus C is equal to M into some constant K2. You can write like this. See, similarly here also we got right A minus B is equal to M into K1. So B minus C is equal to M into K2, right? Now subtract these two. See, when you subtract these two, will get right, or you add. See, better we can add. So A minus B is equal to what? M into K1. B minus C is equal to what? M into K2. Now let us add this. See, when we add, what will happen? Minus B plus B cancel, right? So what we can write here? A minus C is equal to M into what you get? K1 plus K2. See, look at here now. A minus C is a multiple of M, right? See, from this, what we can write? Can we write like this? A minus C is congruent to 0 mod M. Now add C on both sides. What you can write? A is congruent to C mod M. So A is congruent to C mod M, we can write. See, you can take any one example and you can solve. See here, 5 is congruent to B mod M. See, let us take, for example, some number 15. 5 is congruent to, let us say, some mod 4. So when you divide 15 by 4, what is the remainder? We'll get 3, right? You can also take 7 because 15 and 7 both are same, right? They are having the same remainders when you divide by 4. See, 15 when you divide by 4, 4 times 3, 12, remainder is 3. 7 you divide by 4, 4 times 1, 4, remainder is 3. So 15 and 17, they are having same remainders. Now this 7 is congruent to what? Mod 4. What is the remainder? You will get 3, right? See, now from this you can write directly, you can write. So this is A is congruent to B mod M, B is congruent to C. Directly we can write here 15 is congruent to 3 mod 4. See, look at here, is it correct or not? When you divide 15 by 4, remainder 3. When you divide 3 by 4, remainder is 3. So we can do like this. Okay. Okay, take one screenshot. See, next one, second property. See, when you take two numbers, second property you take. So A is congruent to B mod M. A is congruent to B mod M, and C is congruent to D mod M. D mod M. So now here you can add, you can subtract, you can do the things. So how to do? So A is congruent to B mod M is nothing but what? So A is congruent to B mod M is nothing but, we can write A minus B is congruent to, A minus B is congruent to 0 mod M, right? Right, you can subtract. Now A minus B is congruent to 0 mod M is nothing but what? A minus B is a multiple, right? A minus B is equal to M into some constant K1, right? Next one here, C is congruent to D mod M, right? So we can write C minus D is congruent to 0 mod M. We can write C minus D is equal to what? M into some K2, right? Now here you can subtract or you can add. So now let us say this is equation number 1 and then this is equation number 2. See, you subtract once. Now what will happen when we subtract here? Now you can write A minus B, 1 minus 2 you are subtracting, minus of C minus B is congruent to what? So is equal to, we are subtracting 1 minus 2. So which can be written as is equal to M into K1 minus K2, right? Now from this what I can write? A minus B minus C plus D is equal to what? M into K1 minus K2. Okay. Now take A minus B here, A minus C, minus you take here, minus B is equal to what? M into K1 minus K2. Look at here, A minus C minus B minus C is a factor, right? So now how can we write? This is a multiple of M, right? How can we write? A minus C minus of B minus D is congruent to 0 mod m, because it is a multiple of m, right? We can clearly see here m, when you divide by m, we'll get remainder 0. So that is the meaning of this. Now you can add b minus d on both the sides. So you can write a minus c is congruent to b minus d mod m. Okay. Similarly, when you add them, when you add 1 and 2, what you will get? A minus b plus c minus d is equal to what you will get? M into k1 plus k2, right? So what I can write? A plus c minus of b plus d is equal to m into k1 plus k2. Okay. So now what you can write here? Now this one we can write it as a plus c minus of b plus d is congruent to 0 mod m. See, now you can add b plus d on both the sides, right? What you can write? A plus c is congruent to b plus d mod m you will get. See, now here few points we need to understand. We can add, we can multiply. Okay, this is just for understanding purposes. I explained few proofs. See, for all other things, just I'm explaining the properties. See, when we get here, if A is congruent to B mod M, C is congruent to D mod M. See, when the divisor is same, so here M is same. So you can add this. You can add what you can add? A plus C is congruent to B plus D mod M. We can add this, and we can subtract also. How? A minus C is congruent to B minus D mod M. Okay, and we can also multiply this also. So how you can multiply? AC is congruent to BD mod M. AC is congruent to BC mod M, right? And when you are dividing, we have to be very careful. And you can raise to the same power. So when we are dividing, we have to be careful. That I'll explain. Now, if A is congruent to B mod M, we can raise to the power n. So A power n is congruent to B power n mod m. So these are the points you need to remember. See, we can add A plus C is congruent to B plus D mod m. We can subtract A minus C congruent to B minus D mod n, and we can multiply. And here we can raise to the power n, where n is a natural number. We can raise. And when we are dividing a number, we have to be very careful. So when you divide any number by that, so their HCF we have to check. See, for example, 16 is congruent to 12 mod 4. 12 mod 4. See, here you cannot divide by 4 here. You cannot divide by 4. Because 4 and 4 here, these points, this and this HCF should be 1. Then only it is valid. Okay. So that I will explain here with the example. See, so that first we'll see the addition. See, you can add, you can subtract, you can multiply. See, for example, we'll take, see, 5 is congruent to, let us say 1 mod 4. Okay. Now you take another one, let us say some 27. 27 is congruent to what mod 4? 4, 6 is 24, right? 3 mod 4. You can add these two. You can add here. What you can add? 27 plus 5 is congruent to 3 plus 1 mod 4. See, is it correct or not? We can check, right? 27 plus 5, 32. 32 is congruent to 4 mod 4. So this is correct. And you can subtract also here. So what you can subtract? 27 minus 5 is congruent to 3 minus 1 mod 4. 27 minus 5 is what? 22 is congruent to 2 mod 4. This is also correct, right? 22 and 2 leave the same reminders when we divide by 4. So we can add, we can subtract. You can also multiply here. So what you can do? 27 into 5 is congruent to 3 into 1 mod 4. So what is 27 into 5? See, 5 7 is 35. So 5 2 is 135. 135 is congruent to 3 mod 4. Now we can check whether it is correct or not. Divide 135 by 4. What you will get? 4 3 is 12. 12, 15, right? 4 3 is 12. So again, remainder is what? 3 only. So when you divide a number 135 and 3 by 4, they are having same remainders. So like this, see, we can add. See, like this, we can See, we can add like this, we can subtract, we can multiply, and we can raise to the power n also. See, for example, you are taking here 5. 5 is congruent to 1 mod 4, right? When you divide 5 by 4, you are getting 1. See, for example, you take 5 square. 5 square is congruent to 1 square mod 4, right? See, check here, 25 is congruent to 1 mod 4, correct, right? You can also raise to the power 3. Let us say 5 power 3. 5 power 3 means what? 125. See, 5 power 3 is congruent to 1 power 3 mod 4. So we can write 125 is congruent to 1 mod 4. So we can add, we can subtract, so we can raise to the power n. Only when we are dividing, we have to be very careful. So that is, see, when you have like this, if AC is congruent to BC modium, see, then this property is very important. We have to be very careful. Then A is congruent to B modium. So where GCD of C comma M should be 1. GCD of C comma N should be 1. Then only it is valid. Otherwise, so it is invalid. See, you take that should be 1. Otherwise, we cannot take. See, for example, you took one example. So 36. See, 36 is congruent to 6 mod 5. 36 is congruent to 6 mod 5. See, now I can divide by 2. So with the same, right? 18 means you can divide like this. So how can I write 18 into 2 congruent to 3 into 2 mod 5? Okay, this is correct. So you can cancel like this. See, now what is here? 18. 18 is congruent to 3 mod 5. This is correct, right? This is correct method. So this is correct method. Why? Because GCD of 2 comma 5 is 1. GCD of 2 comma 5 is 1. This is the most important point. So this is 1. But you take some other example. So the wrong method. So you should know what to do, what not to do. So let us say here 16 is congruent to 12 mod 4. This is correct only, right? 16 is congruent to 12 mod 4. See, now you divide by 4, for example. You divide by 4. So you can write this one as 4 into 4 is congruent to 4 into 3 mod 4, right? See, now you write 4. Now 4 is congruent to 3 mod 4. This is wrong method. Because when you divide by 4 with 4 and 3, they are not leaving the same reminders, right? This is wrong method. So this method is wrong. Why it is wrong? Because 4 and 4. See, we are cancelling 4, right? 4 comma 4. Same. GCD of 4 comma 4 is 4, not 1. So this method is wrong. So hope you understood all the properties. Okay, we'll continue in tomorrow's session. Okay, thank you for joining this session. Tomorrow I will revise once again these properties and then we'll solve some few problems. Okay. Thank you all, sir. We are going to wind up. It is already.
Yeah, thank you so much, sir. Thank you all. Tomorrow the class is as usual, sharp at 8 o'clock. Have a nice day. Good night to all. Thank you.